AP Calculus, section 5.1, area approximation, page 5. Okay, you should have gotten these programs from your teacher, NumInt and NumInt2. These are programs that estimate area under a curve using RAM. Okay, NumInt draws the rectangles and finds the sums of the areas. NumInt2, that one just finds the areas, or finds the sum of the areas of the rectangles. It does not draw them. If you're not sure how to use those programs, please see your teacher. We are going to use them right now, though, to estimate area underneath y equals 1 over x for x between 1 and 3. I've already plugged that into my calculator on y1. y1 is 1 over x, and I've already drawn a nice graph. Window here, negative 0.5 up to 3.5 in the x's. Y's, negative a half up to 2. And we are going to look at all of these: LRAM, RRAM, and MRAM. For a variety of number of rectangles. And let's start off with just 4 rectangles. To run this program, NumInt, this program does give you the option, tells you, reminds you, enter f of x and y1, draw a graph of f. If you've done those 2 things, then continue. If not, choose 2 and go back. Lower limit from 1, upper limit 3, n is the number of rectangles, so 4. And we see our rectangles drawn here. Notice the cursor is pausing. If you have an older calculator, it's a vertical segment that just keeps kind of flashing. So we, once the program's paused, then you hit enter to get that sum. And that left sum is 1.2833333, a bunch of them. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. One more. Program is still paused. Hit enter again. And there's the RRAM rectangles. Finding that right sum, 0.95. Drawing again. Be careful, these are not rectangles. These are trapezoids here. It's hard for you to see them. We aren't doing trapezoid sum yet, so we'll skip right over that. There's your midpoint height rectangles. And that midpoint sum is 1.08975469. All right, let's go back again, run this program again, but this time let's do 10 rectangles. All right, 10 rectangles has an LRAM of 1.168, 228993. Oops, that's more glary. Trying to fix the glare here. Yeah, it's all glary. All right, RRAM 1.0348956. Trapezoids MRAM is 1.097142094. Okay, one of the things I want you to notice at this point, for rectangles, look how far apart these estimates are. 1.28, 0.95, 1.08. So close, but not as close as down here. Look at these guys. 1.16, 1.03, 1.09, much closer to each other. In because you're getting more rectangles in there, we're getting a better estimate of that area. Let's go back then one more time and let's look at 100 rectangles. Look at this estimate. For 100 rectangles sitting in there, this is going to be a very good estimate of the area. We can't see any space in there that we would have left off. And that is 1.105308584. All right, now I do want to show you something about your calculator and about programs. It's taking a long time to go through this program and wait for it to draw the rectangles. If you want to break a program anytime it's taking too long, just hit on. That breaks the program. Caution, if you choose go to, that will send you into lines of the program, and then if you accidentally hit clear or delete, you erase the line of the program and the program won't work anymore. So if you use that to get out of a program, then choose quit. And we're completely out of that program. Let's look at the other program, NumInt2. Now this one doesn't remind you to put y1, put the function in y1, you just have to know to do it. And we're doing 100 rectangles. Little slow at first, but once these calculations pop up, it's pretty quick. Here's RRAM, and I'm hitting enter in between, so I have time to write them down. 1.09197525. Trapezoid, midpoint, Simpson's rule is an BC topic, so we don't do that one, and we're done. And again, look how close these are. 100 rectangles, 1.10, 1.09, 1.09. We're really close in here. All right, now, taking this one step further and looking at example 5, this table shows the velocity of a model train moving along a track for 20 seconds. I would like you to estimate the distance traveled by that engine using 10 subintervals of length 2 with left endpoints and with right endpoints. We're actually going to do that on the next page, but first, I want you to think. If we plot the data we would have time in seconds on the horizontal axis and velocity in meters per second, inches per second on the vertical axis. And if the data formed one rectangle. So let me put that in. If our data points, they don't, but if our data points formed one rectangle, then the area of the rectangle would be velocity times time, or inches per second times seconds, which is inches, which is a distance. So all of this tells us that the area under a velocity versus time graph is the distance traveled. Please join me for the rest of this problem on page 6.